It's pretty wild to think about, but the massive computational power we use to train top AI models has literally doubled every 6 months. Yet, despite all that juice, we are rapidly hitting a wall. We are just running out of human data to feed these systems. And because of that bottleneck, we're looking at a paradigm shift today that is so profound, it completely redefines the very nature of computing. We are moving rapidly past standard artificial intelligence and into a radically new cognitive paradigm. We call it synthetic intelligence, or SI. So if you think you know exactly where AI is heading just based on the chatbots we use today, well, buckle up. We are about to cross into a completely different frontier.
Okay, let's dive into this by drawing a really clear line in the sand. Traditional AI is, at its core, fundamentally reflective. It looks backward. It uses reflective pattern recognition to statistically interpolate human-generated data. Basically, it's an incredibly advanced calculator trained on words. Synthetic intelligence, on the other hand, it's perspective. It looks forward. SI engages in autonomous, self-directed conceptual discovery. It doesn't just guess the next logical word in a sequence, it actively explores and discovers the unknown.
Here's a quick roadmap for our explainer today. We'll start with the synthetic shift, deconstruct the architecture of a synthetic mind, look at the sandbox and the verifier, apply it to engineering a fuel cell, and then zoom out to look at the epistemic crisis and societal alienation.
Let's get right into part 1, Beyond AI, the synthetic shift.
So traditional AI is stuck in a closed feedback loop. It's built entirely on anthropocentric data. Our human text, our images, our code. Its learning mechanism is statistical interpolation, and honestly, its end goal is just augmentation. It's here to help us do human tasks a bit faster. But SI shatters that constraint. It generates its own synthetic data. Its learning mechanism is autonomous hypothesis generation, and its ultimate goal is true autonomy. It wants to discover solutions that we humans don't even understand yet. By breaking free from human prompts, SI literally breaks free from human cognitive limits entirely. Moving right along to section 2, the architecture of a synthetic mind. To actually pull off this kind of autonomy, SI relies on a deeply complex ecosystem of computational nodes. The first piece is the orchestration gateway. You can think of this as the ultimate traffic controller. When a query hits the system, this gateway instantly decides, okay, does this just need a quick data retrieval or do we need deep, multi-layered synthesis? If it's the latter, the system fires up tools like LangGraph and state-driven engines. It deliberately maps out an explicit multi-step research strategy. This is absolutely crucial because it saves us from the chaotic, random hallucination you get with a standard chatbot. Then we've got perceptual memory. Standard AI is just predicting flat text, right? But SI stores complex environmental rules in dynamic, graph-based databases. It holds on to canonical facts, mathematical realities, and hard structural constraints. This isn't just storage, it's a living, evolving relational repository. So when the SI discovers a brand new rule of physics or figures out an engineering constraint, it updates this graph network, permanently expanding its understanding of how the world's logic actually works. All right, section 3, the sandbox and the verifier. This brings us to the beating heart of the whole system. For the engineers watching, this is exactly where things shift from basic prediction into rigorous scientific intuition. The cognitive sandbox is the true engine of prospective reasoning. Picture a highly secure internal computational scratchpad. In here, the SI isn't just guessing an answer. It is generating hypotheses, writing its own temporary programs, executing custom physics simulations, and deliberately trying to break its own logic. It literally stress tests theoretical concepts in a simulated space before it ever outputs a single word back to the user. Now, what's really interesting about this is the autonomous self-correction loop. The SI writes custom Python scripts or maybe molecular dynamics code just to test a potential solution. Then an automated evaluator runs that code. If the script fails, boom, that negative data is immediately fed straight back into the engine. The SI is actively learning from its own synthetic data through intense self-play, and if it figures out its premise is flawed, it recursively branches out into an entirely new research strategy, all completely on its own. As we talk through this, take a second to consider just how alien this process actually is. By leveraging frameworks like OpenAI's agent SDKs or fully customized DeepSeek setups, SI is using self-play at a massive scale. It generates synthetic reasoning paths, scores them using its own internal reward models, and continuously trains its logic on the fly. It is operating entirely without human intervention, which means it's evolving completely independently from our inherent human biases. But, as we know, wild creativity needs a tether. Enter the verifier. Once the sandbox cooks up a potentially viable concept, it gets shoved straight through this mathematical logic engine. The verifier is essentially the ultimate uncompromising fact-checker. If the sandbox's brilliant new design violates the conservation of mass, or thermodynamics, or strict symbolic logic, the verifier systematically culls it. No exceptions. It mathematically guarantees that only logically sound concepts make it out alive. Let's move to and see how this builds into what we call a neurosymbolic hybrid engine. It's a two-step dance. In step one, a pure neural network taps into its raw, totally alien creativity to brainstorm thousands, maybe millions of solutions. Then, in step two, the hard-coded symbolic logic verifier steps in to aggressively strip out any hallucinations. By merging this boundless creative generation with incredibly strict deductive logic, we get an insanely powerful automated concept discovery engine.
Section 4. Engineering the hydrogen fuel cell. So what does all this abstract architecture actually look like when we apply it to a deep tech engineering use case? Well, it happens in a 4-phase materialization process. First is input analysis. Human engineers simply set the boundary conditions, things like maximum temperature or budget. Second is the sandbox simulation. The ASI writes custom scripts to synthesize millions of different structural geometries. Third, hard grounding. The verifier steps in, calls anything that breaks the laws of physics, and keeps the successful anomalies. Fourth is materialization. Those winning physical coordinates are translated into a perfectly readable engineering blueprint. This isn't just theory, guys. This is literally how we are going to invent next-gen clean energy.
Let's look at the fallout of this in Section 5, the black box epistemic crisis. So the crucial point is, if these systems can autonomously engineer these brilliant physics-defying designs, what happens to the human experts? It's a massive double-edged sword. On the pro side, SI is a huge horizon expander. It practically acts like a bicycle for the mind. It eliminates grueling R&D bottlenecks and suggests incredibly unorthodox research vectors. But look at the cons. If our scientists start relying entirely on synthetic minds to do all the heavy lifting of hypothesis testing, we are looking at severe expert skill atrophy. Over time, a human scientist's foundational intuition and raw problem-solving capabilities could really begin to degrade. And this brings us to the black box epistemic crisis. Imagine you are a top-tier engineer, and you're handed this flawlessly efficient, mathematically perfect fuel cell design. Awesome, right? But because the AI synthesized it through millions of iterations in an incredibly dense, incomprehensible search space, the internal reasoning pathways are entirely unreadable to you. You are forced to rely on a highly effective scientific conclusion that you absolutely cannot mathematically trace or personally verify. That creates a profound sense of epistemic anxiety for experts. Finally, Section 6, societal displacement and alienation. And this brilliantly illustrates our final point. Zooming out to the general public, we faced a massive paradox with the shift to total cognitive autonomy. The pros are just incredible. Hyper-individualized synthetic medicine, custom education, and an abundance economics model that could drastically lower the cost of living for everyone. But the cons are severe. Traditional AI threaten mostly routine tasks, but SI directly targets creative, strategic, and high-level analytical roles. We are risking a massive socioeconomic displacement shockwave, hitting us before society even has time to adapt. But even beyond the job market, there's this concept of cognitive alienation. Remember, the designs that actually survive the cognitive sandbox often look highly organic, completely counterintuitive, and decidedly non-human. Imagine walking through your city, or just using your smartphone, and realizing that the physical infrastructure, the architecture, the daily interfaces, they were all designed by a mind that doesn't think like you at all. As these hyper-efficient synthetic designs start to bleed out into our physical reality, we're going to find ourselves living in an environment optimized by non-human minds. The world itself might just begin to feel profoundly alien to us. Which leaves us with what is really the ultimate challenge of our newly synthetic era. The success of SI isn't just going to be measured by the raw efficiency of its molecules or its machines. It's going to be integrate an alien cognitive framework into human society in a way that elevates our potential, rather than simply rendering us obsolete.
Same old turn.